Okay, so this is for Gifted Accelerated Geometry on Monday, September 14th. And I have several things to show you guys, starting with how to fill out this chart I gave you at the end of the period. It's kind of a summary of what you were exploring in terms of what doing various things to the equation does to the graph. And first I want to start out with adding and subtracting. Adding and subtracting is always a shift, or a translation is another word for that. Okay, inside the function it's horizontal, outside the function it's vertical. Now that's just a general rule, and let me just talk to you about what I mean by inside or outside the function. Basically it means inside or outside of whatever is happening to x. So let's say that it's an absolute value function. That means we're taking the absolute value of x. This would be something happening inside the function. This would be something happening outside the function. That's multiplying by 5 inside the function, outside the function. Let's say that our parent function is, how about, what's another good one? Exponential, 2 to the x. Okay, anything that's happening inside the function would be something that's happening up there in the exponent with x, like for instance this. If it's outside the function, we mean it's not up there with x. It's totally separate from whatever is happening to x. So for squaring, which is quadratics, when we're talking about inside the function, that means it's also being squared. So something that is also being squared, just like x is being squared, would have to be inside parentheses, like this, or maybe like this. That's how we square more than one thing, is we put them in parentheses together. Whereas outside the function, I can multiply by 3 here, and it's not being squared. So it's not, what's happening to x is not also happening to the 3. Same thing here. The plus 5 is not being squared. So anytime it's inside the function, that's horizontal. Anytime it's outside the function, that's vertical. That applies to any type of shift, anything, any type of transformation that could happen. Okay, so inside the function is horizontal, outside the function is vertical. So up here, horizontal, inside the function. If we're adding, and I'm just going over this with darker ink so you could see it better, like x plus 2 quantity squared. This is just an example. That would be a horizontal shift left. With horizontal, what you'll notice is everything's backwards from what you would expect. If it seems like plus would be to the right, well, plus is to the left. If it seems like minus would be to the left, well, minus is to the right. So horizontal is always the opposite of what you would expect in terms of direction. Actually, in terms of more than just that, in terms of several different things. So we'll talk about that again in a second. So with horizontal, plus is to the left and minus is to the right. Vertical is always what you see is what you get. So if we are adding outside the function, that moves it up. And if we're subtracting outside the function, that moves it down. Vertical is up and down. So this would be a vertical shift up, or a vertical shift down. And when we say those things, and that's exactly how you describe it when you're asked what are the transformations that are occurring, we would add like vertical shift up 2 units or vertical shift down 5 units. Okay, so adding and subtracting is always a shift, up, down, left, right. Excuse me, multiplication and division is always a stretch or compression, making it basically narrower or wider. Now inside the function, these we rarely deal with. Okay, so let's go straight to vertical. If it's outside the function, if it's vertical, right here we have a 5 being multiplied outside of the squaring. That's a vertical stretch by 5. And you would think that 5 would be a stretch because you would think 5 would make it bigger. It's a number bigger than 1. If you multiply by something bigger than 1, it usually makes things bigger. Here again, this is a number between 0 and 1. multiplying by a number between 0 and 1 outside of the function is a vertical compression. Compression has another word for it, which is shrink. So compression or shrink is fine. But you kind of do need to know that they both mean the same thing because you might see it different ways on different tests. So that would be a vertical compression by 1/2. Now here again, horizontal, what you see is not what you get. It's vertical, that's pretty much straightforward, but horizontal, it's always the opposite of what you would think. So if you see a number bigger than 1, and we're multiplying by that inside the function, that's actually a compression or shrink. And it's by, and you take the reciprocal of what you see. In other words, if I see a 2, it's a compression by 1/2. And that's what this says over here is recip for reciprocal. So that's a horizontal compression by 1/2. And here we have a number, and I see a number that's smaller than 1, between 0 and 1, 1/3. And that's horizontal because it's inside the parentheses, being squared also. And that's a stretch. Again, 1/3 is a number smaller than 1. You would think that would make it smaller, but because of horizontal being backwards, that's a stretch by, instead of 1/3, 3. Take a 1/3, turn it over, you have 3. Okay? Generally, you will probably deal with this much more than you will ever deal with this. Vertical stretches and compressions are something we tend to look at a lot more. So go ahead, and if you're not sure, assume it's a vertical. If you're not looking at the equation, if maybe you're just looking at the graph, assume it's vertical. Last but not least, we have negatives. Negatives are reflections. Notice that up here we said numbers greater than 1 and numbers between 0 and 1. So nothing with multiplying and dividing has to do with a negative. The negative is its own separate thing. A negative is a reflection. If it's inside the function, that's horizontal reflection, which means going back and forth across the y-axis. If I'm moving across the y-axis, that would be going horizontally. And vertical is across the x-axis. If I'm moving across the x-axis, I'm moving vertically. So again here, that means if my negative is inside, that's across, reflection across the y-axis or over the y-axis. And again, you see this more commonly, a negative out in front of everything, not inside, is a reflection across the x-axis. Okay, now part of this video is I want to go ahead and give you some answers. So once you finish getting that down, let's look at some of what you did in class. Okay, here's what you did in class. Again, sorry it's kind of light. Page 1, let me just go over it with ink and you can check it as I do that. Okay, I described my effect of K on the page 1, number 4, as it shifts up or down. A positive K means you're moving up, and a negative K means you're moving down. And here are my graphs. Let me see if you can see them a little bit better. The solid one here is the parent function. It's number 1. Number 2 is the dotted one up above there. Everything's moved up by 2. And number 3 is down 3 from the parent function. So it's the bottom one out of the 3. Okay, those are vertical shifts up and down. Second page here were horizontal shifts left and right. So here we've got all real numbers. If you are moving to the left and right, the range is not going to change. The only thing that changes the range is moving up and down. So both of these have the same range as my parent function. And for my description, I said it moves left and right. And I gave an example, like x minus 5 would be to the right, or x plus 2 would be to the left. And in these two examples, number 6, x plus 2, that's right here to the left. And number 7, x minus 3, is right over here to the right. On all of these, I'm not doing the create and graph your own because everybody's would be different. All right, number 10. I think you could probably see these. I wrote these a little bit darker. So number 10, here's your answer to 10. 11, 12. Feel free to pause anytime. And number 14, I said it stretches or compresses it or moves it narrower or wider. And it's perfectly fine if your words are different from mine. We had not gotten into the very specific things we did like on just now on the chart. All right, checking answers to the practice questions. Okay, here are your answers that yours should match mine on all of these. Let me see if I can focus it a little bit better here. Not really. Okay, on number 3, let me just read some of these to you so you know. I think they're pretty clear actually. And number 4. All right, on practice B, here's what you should have. Number 2, number 3, here's number 6, number 5, and number 4. Now, one thing you may be asked to do on a quiz or a test is to describe the transformations. So what I want you to do is to add to this, I want you to go ahead, you might want to do it at the bottom here, is just from looking at the equation, describe the transformations. For instance, for number 1, I would say, and you notice that all we've got is plus and minus in number 1. We don't have any times. We don't have any multiplied by anything with no negatives. So I would say this is a horizontal shift left 2, and it is also a vertical shift down 3. So on this, what I'd like you to do is go back and just looking at the equation for these 6 problems, describe them, the transformations that are happening in terms of the language we used right here on this sheet. Okay? This page right here, we will go over together tomorrow. One other thing I wanted to give you a chance to check is your answers to Friday night's homework before you come in tomorrow. So here is that. Look at that. I didn't finish my table of values there. Let me finish my table of values. I get 3, -1, 2, 5. Okay, this is actually, I'm sorry. Let me start with number 1. Number 1, okay. Here's my table of values. And axis of symmetry, I got x is 4, y-intercept is 0 to 17, domain is all real numbers, and the range is y is greater than or equal to 1. Number 2, here's your table of values in your graph. Axis of symmetry, x equals 2, y-intercept is 0, -9, domain is all real numbers, and range is y is less than or equal to -1. Remember to find the y-intercept, you're plugging in a 0 for x. Here's number 3. On this one, you actually had to find the vertex, so we had to use -b over 2a because it wasn't in vertex form. So here's what you should have for your answers there. And here's number 4. That one's in vertex form, so very easy to find the vertex. And on the back, number 5. Here you go. I said sorry on this one because it's a little bit funky on the parabola. And here's what we should have. Number 6 is another one in standard form, so you had to actually plug into -b over 2a to get the vertex, and you can see that up at the top. Number 7, here we go. Remember, you could touch pause at any time to see something more clearly. Number 8, I did not finish. We've got 3, -1 for the vertex, and then let's see, 2, 1, and 4, 1, and 1, 7, and 5, 7. The axis of symmetry is x equals 3. Y-intercept, when I plug in a 0 here, I get -3 squared, that's 9. 2 times 9 is 18. Minus 1 is 17, so 0, 17. Domain is all real numbers, and the range is y is greater than or equal to -1, or from -1 to positive infinity. And that's all I need you to do tonight. Don't forget to go back and do those if you haven't already. Well, finish any of this that you need to finish, the practice A and B from today, and go back and actually describe what transformations are happening for 1 through 6.